Hey guys, so you and me are at it again at 2.5's homework for Algebra 2. So let's go ahead and get to it. 2.5 was all about the fundamentals of graphing linear inequalities. And none of that BS plotted on a number line crap, but we're talking legit Cartesian coordinate XY plane stuff here. So, number one, what is number one? Ugh. Yeah, whatever. I guess I'll allow it since I already assigned it and you guys have already done it. I mean, I mean, I'll pretend you've already done it. Right. Number one, use the four inequalities below, or using the four inequalities below, determine which point is a solution for each one. There may be more than one correct answer. If their answer is none, write none of these. So this is looking at the point 9 comma negative 1. And it wants you to plug it into A, B, C, and D and see which of them are solutions. Now, for an ordered pair to be a solution to an inequality of any kind, when you plug in the ordered pair into the correct variables, you need to get true statements. True statements. I repeat, true statements. So these are our four things, A, B, C, and D, right? And what we have is an ordered pair. This is the problem. You need to plug in 9, negative 1 into each of these and see which one it creates true statements for. So I'm going to go ahead and do that. So we get negative 1 is less than or equal to 2/3 times 9 minus 5. And I'm going to simplify this. Is negative 1 less than or equal to positive 1? Well, yes, it is. Why, yes, it is. So it would be a solution to A. Now let's see if it would be a solution to B. There's a reason why I only assigned you two of these, because they take forever. So you've got 5 times 9, so this is for B here. 5 times 9 plus 4 times negative 1 is greater than 20. Well, that's 45 minus 4 is greater than 20. 41 is greater than 20. Look at that. It is another true statement. I mean, I would bet that 41 is bigger than 20. Why does it say 21? Let's just say 20. Anyway, whatever. So then we get 9 minus a negative 1 is greater than or equal to negative 5. What's a 10? Is 10 greater than or equal to negative 5? Well, absolutely. Look at that. We are in solution heaven. Look at all these solutions. And then you've got the last one. Plug in x and y. So this goes into x, this goes into y, by the way. Negative 4 times 9 plus 1. Negative 1 is greater than negative. Was it 36 plus 1? Is negative 1 bigger than negative 35? Well, yes, it is. Wow. It's a Christmas miracle. It worked out for every one of our points. So, we would just say A, B, C, and D. Number 2, 0, 0. Oh, my favorite point ever, 0, 0. It's gotta be definitely my favorite point. I mean, it's the best mathematically. It just makes everything either explode or disappear. It's the perfect ordered pair. It really does. Things will explode or disappear, and who doesn't like both of those things? All right, I've seen my fair share of Michael Bay movies. I mean, that's kind of a shame to admit nowadays, but whatever. It's true. So I'm gonna do that right here. Plug in 0. When you plug in 0, this is gonna disappear because 2/3 times 0 is 0, and so you're just gonna have negative 5. So is 0 less than or equal to negative 5? Is 0 less than or equal to negative 5? You think about that. Is 0 less than a negative number? The answer is no. No. Not a solution. Then we do this one. Boom, 0 cancels that out. Boom, 0 disappears. Is 0 bigger than 20? No, that's a lie. Not a true statement. Here, you get 0 minus 0. 0. Is 0 greater than or equal to negative 5? Ah, ding, ding, ding. That's true. 0 is bigger than negative 5. Then here is 0. This is 0 again. Boom, that cancels that term. Is 0 bigger than 1? No. Big fat no on that one. All right, so it works on C, and that's it. Boom, that was number 2. All this teal crap, that's number 2. All right, moving on. Man, I've been making videos too much. I'm starting to care a lot less about language and stuff, but I'm still school appropriate, so we're good. Page 112, number 1. Page 112. Let's get this fine page turn-in sound here. Did my air conditioning just click on? Yeah, I guess so. All right, whatever. Number 1 on page 112. Now we're into the good stuff. Now we're into graphing stuff. Yeah, I don't think that'll work. Anyway, whatever. So number 1 says y is greater than x minus 5. Now, I'm going to graph this in the way that I would allow you to graph it. And that is to say, in a pretty sloppy way that is still accurate. So we will call this negative 1, 2, 3, 4, 5, and 1. The first thing you want to do is treat this like the equation. Now, if you cannot graph equations in slope-intercept form, stop, do not pass go, do not collect $200. You need to go back. You need to go back to the other lesson, 2.3 or something, 2.3, and look at that again. You absolutely need to be able to graph lines in slope-intercept form. Not only is it a fundamental aspect of algebra through testing, it is going to be on your test, and it's going to show up again in this class, and it's actually easy. Right? It's so easy you don't even have to do any computations of any kind. You look at this number, you plot that number on the y-axis, then you look at this number in front of x, which happens to be 1. That is the slope. That is 1, and a slope of 1 means you go up 1, right 1, and you plot. Connect the dots. Right? That is how you would graph the equation. The only difference is this is not an equation. It is an inequality. And this inequality is a greater than inequality. And so you got 2 decisions. Do you make a solid line connecting your 2 points? Or do you make a dashed line? Which do you do? That is based off the inequality. If the inequality is an equal to, you use a solid line to indicate that your solution could be on the line itself. However, this is not an equal to, so you need a dotted line. Then, remember, there are an infinite number of xy ordered pairs that work in this, that make true statements. Right? Really, if x is 0, and then y is any number that is bigger than 0, this is just off the top of my head. Any number, it's really any number bigger than negative 5. But, look, hypothetically, if you're not in the camp that you need to do any shading, right, I am of the opinion you need to shade. But, I'm an open guy. I can come to another conclusion if you can show me. But I want to look at ask you this. There is not just one solution that works. There are so many solutions that work. Because I can think of a million right now, literally a million. If my xy was 0, any number that was bigger than 0, this would work. When you plug it in. Because you'd think of some number bigger than 0 is greater than negative 5. Well, that's a true statement. Any number bigger than 0 is bigger than negative 5. So that means all of those ordered pairs need to be indicated in your solution. And it's not just those, there's an infinite number of them. So this is what the shading represents. It represents all of the ordered pairs that when plugged in give you true statements. So that means this ordered pair would be a true statement, this ordered pair would be a true statement, this ordered pair would be a true statement, this ordered pair, when plugged in, would give you a true statement. And the way you figure this out is by testing. I am going to test the point 0, 0, because it is the greatest point, as I've already indicated. I'm going to plug it in and see if it's a solution. Is 0 a solution? By golly, it is. 0 is bigger than negative 5. That means that, all right, so another, I'm going to take a tangent real quick. This line right here, this dotted line, dashed line, however you want to say it, is the great fence. It is the great wall that separates all of the solutions from all of the not solutions. All we have to do is figure out which side is our solutions on. Or are our solutions on? Yeah. Which side is the land of non-solutions and which side is the land of solutions? And to do that, all right, that with that idea comes the idea that everything on this side either is a solution or is not a solution. Everything on this side is the opposite, either is a solution or is not a solution. So, all you have to do is pick one candidate, like your ambassador. Like this 0, 0 is our ambassador to this side of the fence. This little point walks up to the inequality and says, hey, do I work? And if so, can you shade towards me? And you check. This ordered pair is like your little baby ambassador. And you plug them in, and if you get a true statement, then yes, look at that. This little baby point is your solution, and you shade towards it. You go towards the light, towards the point. However, if it makes a false statement, then it's a dirty liar, and you shade away from it, and you don't want it as a part of your group, right? So that is the moral of the story. Man, this is going on for a long time, but anyway, that's how you do that. So moving on, I'm gonna sort of breeze through these now. Number 2, you've got your ordered your xy ordered your xy plane. Why can I not talk? I know why I can't talk. It's because I've been doing it all day. And making videos, talking to myself in a room that's empty. It's got nothing but microphones and televisions and stuff and monitors and cables and whatnot. So, 2 ways you could graph this. You could get it into slope-intercept form, or if you fancy it, you could graph it finding intercepts. Why did I write a 0? I'm going to graph this using intercepts, okay? So to find the x-intercept, I plug in 0 for y and solve for x. So this is finding the x-intercept. If you don't know how to do this, this is also something you should already know how to do. To find x-intercepts, plug in 0 for y and solve for x. So at 4/3, 0, that's my x-intercept. And to find the y-intercept, you plug in 0 for x, solve for y. So there's our y-intercept. Plot the 2 intercepts. 0 or 4/3, 0 we'll just say is here. And then 0, -2 we'll say is here. You plot these 2 points and connect the dots. However, do you do a solid or a dashed line? Student, do you do a solid or a dashed line? You do a solid line because it is an equal to. If it's equal to, you do solid. If it's not equal to, you do dashed. Solid line. Now you need to pick an ambassador to figure out which one to shade. I choose the beautiful, amazing, ever youthful point 0, 0. It'll forever be in its prime. You get it. So plug 0, 0 in and see if it's a true statement. 0 is less than 0, or 0 minus 0 is greater than or equal to 4. Is 0 greater than or equal to 4? No, it's a dirty liar point. 0 is not bigger than 4. That means, since this was like an ambassador for all of the points on this side of the line, that means that all of these points are not solutions. Not solutions. That means you don't want to shade that way. So I'm going to erase that. Our solution lies over here. This is where your solution is. Look at that beautiful shading. So there's your solution. Number 5, 5, 7, and 5, 6, 7, and 8. 5, 6, and 7. Now we've got 5. It says y is less than, -2. Now, you would need to know how to graph y equals negative, or y equals negative 2. This is a horizontal line through the y value negative 2. Every value on the line has a y value of negative 2. So it has to be horizontal. And you will do a dashed line because it's not equal to, and you will shade the y values that are less than negative 2, which happen to be negative 3 and negative 4 and negative 5 and so on. So you will shade this way. What is like the graffiti? Dry media? Ooh, look at that. It's like a little crayon. Look at that. I've got graffiti. Oh. Wow. Cool beans. Awesome. Look at that. Anyway, moving on. It's getting late. I like to have fun. So, sue me. Y is less than negative 1/2 x minus 3. Plot this. Graph it. So, again, slope-intercept form. This is your intercept. This is your slope. You absolutely need to be able to do this. Negative 3 is the y-intercept. So that's where it crosses the y-axis. So you plot the y-intercept. Slope of negative 1/2. That's down 1, right 2. Down 1, right 2. The reason you're going down is because the 1 is negative. Down 1, right 2. Connect the dots with a dashed line, since you're not equal to, and shade appropriately. Pick your ambassador. My favorite beautiful point, 0, 0. 0 is less than 0 minus 3. Is 0 less than negative 3? Sadly, 0, 0, you are again not a solution. That means nothing up here is a solution. I'm going to use my graffiti here. It's going to be awesome. Oh, look at that. Look at that beautiful graffiti. So 0 is not less than negative 3, so you shade the other way. That's it. And now number 7. Final problem. Number 7. It is x is greater than or equal to 6. X equals 6 would look like this. Right, that's 6. The reason I did a solid line is because it's an equal to. Right? Equal to means solid line. Right? Then you're shading everything greater than the 6. So that's all the x values bigger than 6. So that's 7, 8, 9, 10, whatever. So all of these values here. Oh, I have a bristle brush. Let's see what that looks like, shall we? Oh, look at that. That kind of looks like those neon signs. Looks like there's neon signs that have this sort of look to them. I can see it. Hang on. We got this. Some sort of neon. I want like a neon red, but I don't think such a thing exists. Oh, maybe this. Here we go. Yeah, I can totally see that. And then you got like your thin little wire going around the outside. It's gonna be thicker than that. Mr. Dibbles. Homework videos open for business. All right, we're done here. It's a wrap. Let's call it. That was 2.5. Yeah.